Alright, here we have another example, and we're going to be finding the vertex, the focus, the directrix, the endpoints of the lattice rectum, and we're going to be graphing this thing. Now, if you'll notice, this one automatically looks different because we've not had, both an x and a y, and then one of them squared. This has been a little bit different than anything we've seen before. So, and there's a reason for that. This is not in our good standard form, so we need to force it into that form. Before we can do anything else, we actually have to complete the square in order to get that in the proper form. So if you'll remember, completing the square means that you have to group your variables together. In this case, since y is squared, this is the only one that we have to complete the square on. Remember, in your parabolas, you only have one of the variables that's squared, so you only have to complete the square one time. So we're going to put y squared minus 2y and then leave a space to be able to complete the square equals 8x minus 1. We're going to put everything else on the other side. Now your procedure for completing the square was to take half of the middle term, so half of negative 2 would be a negative 1, and then we square it, so that would be a positive 1. Now because we added it to one side, we have to also add it to the other side to balance everything out. And by completing the square, now this will factor into y minus 1 squared equals, and then our 8x. If you need to review completing the square, you can also go back and do that because that's an important topic to review. Now that it's in this form, though, we can see much better exactly what's going to happen here. Because this is a y squared, then that tells us that it's going to open either to the left or the right. Remember, your y squared generic formulas follow the pattern of y minus k squared equals plus or minus 4a times x minus h. So we can read off what our h and our k is just by looking at the formula here. That means that our vertex is going to be at the point 0 because there is nothing being subtracted from the x's, and 1 because that's being subtracted from the y's. So our vertex is at the point 0, 1. I'm going to go ahead and plot that as we go. Now remember, since the y is squared, that's telling us that this thing is going to open either to the left or to the right. Because this is positive here in this 4a position, that tells us that it's going to open to the right. So since this opens to the right, kind of picture that in your head, that going this way, that tells us where we're going to put our focus. And we're going to know about the focus because look at what's in the 4a position. It's an 8. So if 4a is 8, that means a has to be 2. That tells us it is 2 units over to the right to get to the focus, which would be the point 2, 1. It also tells us that it's 2 units backwards to the directrix line, which would be x equals negative 2. And because the lattice rectum is 4a units long, that says that our lattice rectum is going to be 8 units long. We'll have half on one side, half on the other. Since this parabola opens to the side, our lattice rectum will be vertical. So we're going to go 1, 2, 3, 4 units up. That would be the point 2, 5. And we're going to go 4 units down. 1, 2, 3, 4. And that would be the point 2, negative 3. Now that is what's going to help us draw in our parabola, and we will have completed the problem.